Dragon separated from Falcon 9 was 210 kilometers by 190 kilometers. Those values represent the orbit apogee, or the highest point over the Earth, and the perigee, the lowest point over Earth. That means the orbit is not a perfect circle. About 47 minutes after liftoff, Dragon executed the phase burn, which was the first of 5 major burns required to raise Dragon's orbit and position it for approach to the International Space Station. We're going to see Dragon raise its orbit using those Draco thrusters over the coming hours as it chases down the space station. Once the crew wakes up in the morning, we'll have a number of events that will eventually lead to docking targeted for 2:10 a.m. Pacific time, 9:10 GMT on Saturday. However, there have been some milestones to occur while the crew were asleep. We had an extra phase burn at 2:02 p.m. Pacific time, or 21:02 GMT, which lasted 21 seconds and was based on what our orbital data showed us, how Dragon's flight computers calculated that it needed some additional burns to get positioned for the rendezvous. There was another phase burn at 5 p.m. Pacific, or 0 GMT, lasting 30 seconds. Once again, just aligning Dragon with where it needs to be to approach the International Space Station. And before the Dragon crew wakes up, we will execute the boost burn.
The boost burn is targeted to start at 6:25 p.m. Pacific time, and after this burn, our crew will be in an orbit where Dragon's apogee, or highest point, will be 10 kilometers lower than the station. We'll have 3 major burns left before we get to integrated operations and Dragon's final approach. About 10 minutes after the crew wakes up, we'll execute the close co-elliptic burn at approximately 7:10 p.m. Pacific time. The close co-elliptic burn will place Dragon on an orbit roughly co-elliptic with the space station, meaning we're maintaining an orbit roughly 10 kilometers lower than the station the entire way around the Earth. That's in contrast to being only 10 kilometers lower than the station during Dragon's apogee, or its highest point in orbit, which was achieved by that second burn, the boost burn. The close co-elliptic burn will be another long firing of Dragon's Draco thrusters, with the burn expected to last just under 10 minutes.
After the close burn, the crew will be able to enjoy some breakfast, and then at 9:06 p.m. Pacific time, or 4:06 GMT on Saturday, we will execute the 4th maneuver. That's the transfer burn. The transfer burn will raise Dragon's apogee, the highest point of its orbit, to just 2.5 kilometers lower than the station. Everything will be rounded out with a final co-elliptic burn at 9:53 p.m. Pacific, or 4:53 GMT, and that helps us maintain that constant orbit lower than the station, this time just 2.5 kilometers below. We expect this to be a shorter burn lasting just over 30 seconds. After all those major burns, we'll get into the approach initiation and final stages of Dragon's rendezvous with the space station. And this is also when integrated operations begin between the Dragon control team here in Hawthorne and the space station flight controllers in Mission Control Houston. The teams will transition to integrated operations, working together roughly 45 minutes prior to approach initiation.
And during the approach, SpaceX flight controllers will work in tandem with the NASA team in Houston to activate and test out a number of systems on Dragon, including bidirectional communications with the station using the C2V2 system, which stands for Common Communications for Visiting Vehicles. They'll also set up data stream from Dragon to the station, giving another path for Dragon telemetry to come to ground and giving an additional command capacity to astronauts aboard the station. They'll also maneuver Dragon to the proper attitude and initialize the navigation sensors used for the methodical approach to the station.
At approximately 12:40 a.m. Pacific time, 7:40 GMT, Draco thrusters on Dragon will fire for the approach initiation burn when Dragon is at about 2.5 kilometers below station and just about 7 kilometers behind it. This will swing Dragon up until it's about 400 meters, around a quarter mile, directly below the station. This maneuver will also move Dragon inside one of 2 checkpoints around the station that requires a set of go-no-go poles with the different control teams. The first checkpoint is the AE, or the approach ellipsoid. It's an imaginary shape measuring 4 kilometers by 2 kilometers by 2 kilometers, essentially a large 3-dimensional oval. And before Dragon is given permission to move inside the approach ellipsoid, the capsule is configured to be on what is known as a 24-hour safe trajectory. This means that if Dragon lost all control to its thrusters, it would be at least 24 hours before its trajectory would move inside the approach ellipsoid.
At 1:39 a.m. Pacific time, the NASA and SpaceX teams will do a go, no-go poll to move Dragon inside the keep-out sphere, another checkpoint that consists of an imaginary sphere around the station with a radius of 200 meters. Flight controllers use this to monitor all arriving and departing vehicles to the International Space Station. This is also another chance to confirm all of the guidance, navigation, and control systems are working correctly on Dragon before moving closer to the station. It carries a similar requirement to the orbital trajectory that if Dragon were to somehow lose control of its thrusters, it and the space station would be safe for 4 orbits or about 6 hours, rather than the 24 hours required to enter the approach ellipsoid. Once Dragon arrives at 400 meters below the station, it will be at what is known as waypoint 0 and will be the first checkpoint during our approach. The vehicle can hold here at 400 meters, but if all systems are looking good, it can just continue on to its approach to waypoint 1.
Dragon's move from waypoint 0 to waypoint 1 excuse me, will swing it up and out in front of the station, arriving at a distance of approximately 220 meters. At this point, it'll be on what we call the docking axis, which essentially means it's directly in front of the docking port. The crew is headed to the Node 2 forward port, the most forward port on station, and that's where Dragon docked just over a year ago on the Demo 2 mission, where Crew 1 originally docked upon their arrival in November. Just a few weeks ago, Crew 1 moved their spacecraft from the forward-facing port to the Node 2 space-facing port in a port relocation maneuver. This Node 2 port is where one of 2 international docking adapters is located, installed for these new commercial spacecraft flights, as well as any other future spacecraft that use that international docking standard.
Once Dragon is only 20 meters away from waypoint, once Dragon is only 20 meters away from International Docking Adapter 2, it is at waypoint 2. The spacecraft will then focus on aligning its docking system with the International Docking Adapter. We may hear the call out for CHOP, which stands for Crew Hands Off Point, a little less than 30 seconds before docking, and at this point, any aborts will have to be done automatically by Dragon.
And the moment we've all been waiting for is when our crew arrives at the space station. Dragon will fly in and make